Alain, Edward, and myself, Aleecah, will be presenting on week 10's content, which included integrating using trig identities and differential equations. Our objectives for this presentation: we will be explaining what it means by integrating using trigonometric identities. We will then move on to solving integrals using trigonometric identities. And after, we will explain what it means by differential equation and solve differential equations by first order.
So throughout this semester, we learn how to integrate using various type of techniques, right? We know integrating by parts, integrated by partial fractions. We know use substitution, but today we will be using trig functions, right? Why we use trig functions is because sometimes it's easier to integrate and it's a lot less headache to integrate. So the equation that I have here today is the integral of sine 25x cos 22x dx, right? So now we can look at this and we can actually remember that we have a trig formula that looks exactly like this, which is sine alpha cos cosine beta dx, right? And that would equals to this same function right here, which is a half sine alpha plus beta plus sine alpha minus beta, right? So what we will do is that we will transform this function. This is a product to sum, by the way. You can use any other things like half angle and those other types of formulas, but this one would work best with product to sum. So you will see other trig functions that you would use a different formula for, right? So then we will transform this to that, which is integral of sine 25x times cosine 22x dx is equals to the integral of a half times sine 25x plus 22x close bracket plus sine 25x minus 22x close brackets, and of course close brackets again dx, right? So what will happen now is that we will just factor out the half and we will simplify what's inside the angle, right? That gives us a half integral sine 47x plus sine 3x dx, right? And now what we will do is integrate these. And this will give us a negative cosine for both, right? We know that. And you know when we integrate, we have to take out the angle at the front, right? And we put the 1 over it, right? Because we have to apply the integral rule towards the angle too, right? So this will give us a negative 1 over 47 cosine 47x minus 1/3 times cosine 3x plus c. So a half multiplies that entire thing, right? So what will happen, what I normally do is I simplify the whole thing because I just like simplifying it. Some people would like to leave it like this, right? So this will then equals negative cosine 47x over 94 minus cosine 3x over 6 plus c. So that's how you use trig functions, specifically product to sum. You can use the others. That's how you integrate using trig functions. Thank you.
So we're given this integral that contains a trigonometric function, that is the integral of cosine cubed x dx, which can also be written as the integral of cosine squared x times cosine x dx. And we will be using trigonometric identities to solve this, specifically the Pythagorean identity, which states that sine squared x plus cosine squared x is equal to 1. And if we subtract sine squared x from both sides, we can obtain that cosine squared x is equal to 1 minus sine squared x. We will be using the substitution method to solve this integration problem. So we will let u equal sine x and du equal cosine x dx. So once we have found our substitutions and our trigonometric identity that we'll be using to find our final answer, we can now begin to substitute into the original problem. So we can recall that cosine squared x is equal to 1 minus sine squared x. So we substitute that where the cosine squared x should be. So that's the integral of 1 minus sine squared x times cosine x dx. And now we substitute for u and du, letting them equal to sine x and cosine x dx. So we have the integral of 1 minus u squared times du. Now we can go ahead and integrate. So once we integrate 1, that will be equal to u, and integrating u squared is equal to negative 1/3 times u cubed, plus our integration constant that we always need to add once we have already integrated. So we can substitute back what we originally know as u, that is equal to sine x, into our final answer. So we have sine x minus 1/3 times sine cube x plus constant of integration, which is our final answer.
X minus x squared over 2 plus. Yes, indeed. What are a differential equation? Well, a differential equation is an equation that relates one or more different functions and their derivatives. In class, we were taught to solve differential equations like first order differential equations, second order differential equations, and homogeneous differential equations. But today, we'll be focusing more on first order differential equations. But first, let us try a common example of a differential equation. Come. Okay, so we are given this common differential equation, which is y squared dy by dx equal 1 minus x. So the job here is to separate the y variables and the x variables with their respective dy and dx. So therefore, we will get that dx is multiplied here, and dx is also multiplied by this side, on the right side. So therefore, we get y squared dy equal 1 minus x dx. From the next step is to integrate. So we integrate both sides, leaving the integral of y squared dy equal to the integral of 1 minus x dx. After integrating, we will get y cubed over 3 equal to x minus x squared over 2 plus the integration constant c. We will then make y the subject. So we will multiply both sides by 3. So we will get y cubed equal to 3x minus 3x squared over 2 plus 3 times the integration constant. But however, this is the integration constant, so it remains just capital C. So it will be y cubed equal to 3x minus 3x squared over 2 plus c, which is the constant of integration. Okay, now we are going to solve this differential equation by means of first order. So we are given an example, x multiplied by y prime plus 4y equal to 2x cubed. But the general format for first order differential equation is given by y prime plus p of x y equal to q of x. So therefore, we must write this in that format. So we will divide all the sides by x, and it will be left with y prime plus 4 over xy equal to 2x squared. So we know that the p of x is equal to 4 over x because it is the term next to the y, and the q of x equal to 2x squared because it is equal to q of x, like in this format. And from this, we can find the integrating factor. And the equation for the integrating factor, which is also I of x, is equal to e up by the integral of p of x dx. So we know that p of x is 4 over x, so it will be e to the power of integral of 4 over x dx. And integrating that, we get e to the 4 ln x. But this is also written as e to the ln x to the 4th. And ln has a base e. So that means e and the ln of e will cancel out and will only be left with x to the 4th. The equation to solve first order differential equation is given by y equal 1 over the integrating factor I of x multiplied by the integral of I of x times q of x dx plus c. So substituting the values of q of x and I of x back into this equation, we'll get y equal to 1 over x to the 4th multiplied by the integral of x to the 4th times 2x squared dx plus c. So after solving the integral of x to the 4 times 2x squared dx, we are left with 2x to the 7 over 7 plus c. So now the equation is y equal to 1 over x to the 4 multiplied by 2x to the 7 over 7 plus c. Now we distribute the 1 over x to the 4 into these terms, and we are left with y equal to 2x cubed over 7 plus c over x to the 4. And the general solution is now y equal to 2x cubed over 7 plus c x to the negative 4th power.